What if we had a molecule like this? Versus a molecule that looked like this. And I asked a very simple, straightforward question. Which one is the most basic? Which one can act as is the stronger base? Okay, so bases typically have a negative charge, and they typically have lone pairs. They could be neutral with lone pairs, or they can be negatively charged. Now, there's always going to be an exception to that rule. That's why I'm saying generally. So to answer that question of which is the most basic, you have to follow a procedure. You have to follow steps. If you're just going to memorize what those molecules look like and just memorize that one's more basic than the other, then you're going to lose. You can't memorize molecules. You have to learn principles. So the first step that you need to do is convert the base in question into its conjugate acid. Is this even working, the microphone? We're good? So in order to form the conjugate acid, what's the definition of an acid? It donates a proton. So if we have the base, then all we have to do is add a proton. So where are we going to add that proton? We're going to add the proton where the negative charge is. And so we do this also with the nitrogen at the hydrogen there. Now we have the conjugate acids of those bases. Now we ask us, the second step is a simple question. What are the pKa's of those acids? And I told you guys to memorize the very basic common functional groups. So we have a alkyne. What's the pKa of an alkyne? 25. And the pKa of an amine? 38. Okay. So that's your second step. Finding out what the pKa's are. Now we are going to reach a point that a lot of these problems, well, let's put it this way. What if you don't have the pKa's memorized, or what if they're not given to you? Can you still solve problems? And the answer is yes. Not in today's lecture. You're not going to learn how to do that. That's the next lecture. And so in the next lecture, I will have taught you by the videos the cardinal rule. And the cardinal rule is a way to look at molecules and assess which one's more acidic or which one's more basic when you don't have pKa values. The textbook does a different method. Well, yeah, it gets you to the same answer. It's called the REO technique. Okay, and you can read your textbook and it shows you the REO method. My videos teach us the cardinal method. You get to pick on which one works best for you. But pick one, and I'm just giving you guys options, okay? So you guys get to pick which one resonates with you better. So that's going to be next lecture. But for this lecture, let's assume you know the pKa's or they're given to you. So the next step is to identify which one is the stronger acid. Is it the one on the left or the one on the right? The one on the left, because it has a smaller pKa. Right? So that's a stronger acid. Once you find the stronger acid, its conjugate base is going to be the weaker base. That's how I like to view it. When I'm comparing molecules, I find the strongest acid, and then I know its conjugate base is going to be the weakest base. You could have also looked at it from a different angle. You could say, hey, this is the weaker acid because it has a larger pKa. Hence, that will make this the stronger acid, or stronger base, sorry. Do you see that relationship there? So you guys get to decide how you want to view it. But you guys got to be very careful to read the questions carefully on the test. Because I can ask questions like, what is the stronger base? What is the weaker base? And one thing about college and just education in general, one thing that I hate and I despise are cheaters. Can't stand them. And I try to keep the playing field level, okay? And so what I typically do on exams is everyone's going to get a slightly different version. And so if you're sitting next to your neighbor and you don't know what's going on and you're cheating, your exam may ask for the weaker acid, but your neighbors may be asking for the stronger acid, and then it's really easy to catch that. If you're copying off of someone but you didn't read the question. So, this could be a warning to you to either read the question really well before you start cheating, or just don't cheat. Okay? So once we've identified that, then we can answer the question, right? What was the question that I asked? Which is the stronger base? Is that what I asked? So there it is. That's the stronger base in that particular example. Okay? Does that make sense? And that process? Now, let's look at a different example, class. It's the same principle. That versus this. Which is the stronger base? So what's step one? Draw the conjugate acid. So that begs the question, where do I put the hydrogen? Do I put an additional hydrogen on this carbon right here? No, because it already has 3 hydrogens. If I tack on another one, then I'll break the octet. Every position, every carbon there already has its maximum amount of hydrogens. I can't add any more. But what did I say? Bases typically have what? Lone pairs or a negative charge. So where's that hydrogen going to go when I want to look at its conjugate acid? I would stick it on that guy right there. So now what's the formal charge? That has to be positive. And 1 lone pair. Now with the alcohol, we know a neutral oxygen atom has 2 lone pairs. When we look at its conjugate acid, we would have to put the hydrogen on the oxygen atom. Now these structures right here, I haven't asked you to memorize the pKa's of molecules that look like that. So up to this point in your career, I would have to give you the pKa values. But come test day, you will have been taught the REO method or the cardinal rules, and so I won't need to. But for this purpose, I'll tell you the pKa. It's negative 7.3 for that guy and negative 2.4. So if I ask you with those, which molecule is the stronger acid? What would you say? The one on the left, because it has a smaller pKa. So that would make this guy the weaker base. So by default, that guy right there is the stronger base. Make sense? All right. Now that we can understand that, now we can look at a reaction. What if we take butoxide and we treat that with water? And that's going to be an acid-base reaction. What are the products going to be when you take those 2 species and add them together? Well, you first need to identify which is the base and which is the acid. And bases typically have a negative charge or a lone pair. So we see lone pairs there. Yeah, so that could act as a base. Water acts, it can behave both. It could be an acid or a base. But then this guy over here has lone pairs and a negative charge. So that one's going to be the stronger base between the two. And so we're going to call this guy the base because it has lone pairs and a negative charge. And then by default, the other one has to be the acid when we're doing acid-base chemistry. Once we've identified that, now we can draw the mechanism. And the mechanism is showing how the electrons flow to form bonds. So we're going to take this lone pair right here, and it's going to come and form a bond with that hydrogen bond, or with that hydrogen atom. If I just leave that one orange arrow, hydrogen has a bond right there, and this is now turned into a bond. And at this point, we know that hydrogen can only form how many bonds? One bond. So we have to break the oxygen-hydrogen bond right there. And so when we draw the product here, we have our oxygen atom. Those lone pairs are still there. We use this lone pair to form the bond with the hydrogen. So this hydrogen is now there. Plus, we have, and what else does that oxygen have? The two electrons in that bond are now a lone pair. And so this oxygen, which is called this molecule is called a hydroxide. What formal charge is on the oxygen? -1. Nice. Okay. Now we have that. Let me give you a warning. And when I give this warning, 50% of you guys don't listen, or there's some sort of confusion. The way I drew those orange arrows are critical, because those orange arrows are showing you where the electrons start. The start of a mechanism arrow, the beginning there, shows you where the electrons are, and then the head of the arrow shows where the electrons go. And so we see that that lone pair forms a bond with this hydrogen. That's the flow of electrons. Many students will make this mistake, and please never ever do it. If you're tempted to draw it like this, just stop and say, I may not know why this is wrong. I just remember Dr. Lawrence was screaming at me, said never ever do this. So just don't do it, class. And that is, you say this hydrogen is coming over and swapping onto that oxygen. You can't do that. That arrow, the way that you're intending it, is saying, hey, the hydrogen was here. Now we've moved the hydrogen over there. That's not mechanism arrows. Because where are the electrons around that hydrogen? You see the start of the arrow right there? Where's the electrons? They're not there. You cannot draw an arrow if there's no electrons. So if you have a mechanism problem and you need to move a hydrogen, never ever draw the hydrogen just hopping over. Never do it. And we'll talk more about this a little bit later. It's a big issue. Do not draw hydrogens hopping around. Now that we've found what the products are, where's the conjugate acid? Where's the conjugate base? Now remember, conjugate acid, conjugate base are pairs. So look at the structure. Tert-butoxide turned into the tert-butanol. So if that's the base, then by default that has to be the conjugate acid. And if the water started out as an acid and went to the hydroxide, that would have to make that the conjugate base. Do you see that pair there? Okay. Now we've figured out the equation. What does these arrows right there mean? Equilibrium. So that means at equilibrium, the net flow of going to products and the net flow back to reactants is the same, right? It's equal. But before we get to equilibrium, we're going to get to a point that one side is favored over the other. And so we want to ask ourselves the question, are there more of these molecules at equilibrium or more of these? Said another way, we want to find what side of the equation is favored at equilibrium. And it's really straightforward, class. You have to find the acids and find their pKa's. So I've identified water as the acid, and I know its pKa should be around 16. Its exact pKa is 15.7. So I find the acid on the reactant side. Now I go to the product side. Where's the acid over here? Well, we've already identified it, right? It's this guy, the terbutanol. What's the pKa of an alcohol? 16. 15 to 16-ish, right? That's what I told you to remember. And that will do you a lot of good. This molecule actually is 18. Do you need to remember that? Memorize that? No, you don't. Because I told you 15 to 16. Now, as you can see, is that a true statement for all alcohols? No, it's not. There's so many exceptions to everything that I tell you. That's just how life is, right? You take your college physics and then you get to advanced physics and they'll be like, we kind of lied. And that happens in chemistry. I don't know if that happens in biology. But okay, so once you find the pKa's, your next thing that you need to do is find the weaker acid. That's the weaker acid because it has the larger pKa. So at equilibrium, it favors towards the weaker acid. That's all you have to do. Find your acids, find their pKa's, identify the weaker acid, and that's where equilibrium is going to favor. So it's going to favor to the right, or you could say it's going to favor the products. Follow? Does that make sense? Okay. The next thing that we need to know is how far to the right? Is it 10 times more to the right? 1,000 times more to the right? We've got to get some kind of number. And so to figure out which side is favored and by how much, we use the pKa's once again. Now all we have to do is take the pKa's. 18 minus 15.7 is what? 2.3? 2.3. So this is not the answer. It is not 2 times more favored to the right. That's an incorrect statement. Because these values right here, they're logarithmic. pKa's are what? The negative log of a Ka. So it's logarithmic, so that means we have to actually raise that 2.3. It's 10 raised to 2.3. So approximately, what does that number equal? 10 raised to the 2. 100. So we can say that when you do this reaction, when you put those two reagents together in some water, it's going to be favored to the right by 100 times. Put another way, for every 100 molecules of your terbutanol, you're going to get 1 molecule of your terbutoxide. That's what that's saying, right? Isn't that 1 times 100 is 100? That's what 100 times means, right? So it's favored to the right by 100 times, not 2 times. Good. Okay, so for class on next Tuesday, I want you guys to practice this problem on your own and come with an answer. There it is. Follow, give me the answer of what I just did up here. So you need to identify the base, the acid, the conjugate base, the conjugate acid, find the pKa's, tell me at equilibrium what side is favored. Okay, there's your problem. And make sure you have an answer for me on Tuesday. Do we have any questions? No questions? Okay, so I have an assignment for you that's going to be on Canvas. I have to log in real quick, but you're going to start this assignment. Pay attention to the due dates. And as I'm logging in, I'll just say something about due dates. Let's see. And that is talking and trying to type in a password. It's not working for me right now. Due dates. If you're a minute late, are you late? Yes, you're late by 1 minute. I'm not going to just differentiate between being 1 minute late and 30 minutes late. They're the same to me. It is very difficult for people to email me and say, hey, I was in class, I did submit the assignment, but it was still late. Can you change the grade for me? How do I know that you were actually here? How do I know that you weren't out there doing whatever you want and you noticed there was an assignment and you uploaded it real quick? I can't differentiate. It's not that I don't have sympathy for people that make a human mistake of submitting something late, but it's near impossible to know if it's legit or not. Okay? So it's just easier for everyone involved. It is your responsibility to make sure assignments are uploaded by the due date. And if you're late, you're late. Does that make sense? Okay, so let's log in here. And you guys can work together. Let's see. Okay, so under modules, you will find this assignment called Acids Part 1. I need to make it available to you guys. And you guys are what? You are CHM Section 4. Due dates by the end of class. When does class end? 4:15. So I'll give you guys some grace period. 4:30, but not AM. PM. I think that looks legit. Save. So now you guys should be able to see that on your Canvas. So start working on that. And make sure it's uploaded by the due date. Has that come through for you guys? Something yet? No, you're section 4.